Okay, here is an explanation of number 4 on page 230. So this describes a snowmobile, and it is moving, and it accelerates or speeds up to a speed of 28 meters per second from 6 meters per second. And that takes a total of 60 seconds to do. So question or part A asks us to sort of draw this situation. Notice how, I guess I could have drawn the snowmobile over here, but maybe I got a little lazy. But notice how the arrows, the length of the arrows, corresponds to the actual magnitude or amount of the velocity. So we have a short arrow for 6 meters per second and then a longer arrow for 28 meters per second. Okay, part B. What is the snowmobile's change in momentum? What is the impulse on the snowmobile? So, change in momentum is the same thing as impulse. Sometimes the force exerted in these situations is described as the impulsive force, but when something, like the book, refers to impulse, that is simply talking about the total change in momentum. So, the momentum of this changed from something to something, and total momentum changed is going to be whatever it is. So, change in momentum, delta P equals mass times change in velocity. So the mass of the snowmobile stays the same. Change in velocity is like this. We have final minus initial velocity. So our delta P, or change in momentum, is 5,280 kilogram meters per second. These are the units for momentum. There's nothing fancy. I like to joke that these are called Tourvilles, but well, that's a lie. They're just called kilogram meters per second. So this is the change in momentum or the impulse. Part C, what force or average force, because the reality is it'd be kind of hard to have a constant force accelerating that snowmobile, but whatever. The force required is going to be, excuse me, change in momentum divided by change in time. This is a useful formula. So change in momentum divided by change in time gives us something like a force of 88 newtons. Notice how if this happened over a shorter period of time, if t, delta t, were smaller, then the force required would be larger. Okay,